Hi, we'd like to think and explore what does it really take to design a SIEM solution, and what is the direction of data flow if we have to do that. So in this sheet, from left to right, this is the direction of data flow, and with processing of data if needed on the way. And the final destination of the data is either a visualization layer or a reporting layer. Reporting could be ad hoc, it could be, customized, standard GUI, etc. Or till the data triggers an external workflow, right? So let's see those in detail. So what really are the sources of data? These are at the leftmost. So in a sense, the sources of data are pretty much every data that we need to make a decision with respect to the feature set of a SIEM, right? So the feature set of a SIEM is that it has to give a 360-degree view, real-time alerting insight into any security-related incident or security-related activity that a SOC manager has to be aware of and react to. All right, so what would those data sources be? The data sources are, in a sense, at their core, are either application logs, or they could, logs in the form of a file log. They could be application API. Let's say an application could be producing data directly through an API over the network sockets, etc. And of course, the code source of data is also whatever is passing through the network traffic, that is to say, right? So these are the tier one data sources. And let's say some of these applications which are particularly of interest to us are firewalls, antivirus, and IDS applications like Snort, very rich applications like Zeek, which consume the network traffic data. And in turn, based on their configuration, they can create logs of various types. Moreover, there are other endpoints. Endpoints are basically software entities that reside on a computing node from where data is to be collected, right? So there could be other endpoints like FluentD, and the Beats framework of Elasticsearch has many useful endpoint software like WinLogBeat to collect the data from Windows endpoints. This data typically, is further sourced from the operating system. And that reminds us we have to mention the OS logs here. They are also key sources of data. And likewise, FileBeat is an endpoint from the Elastic family, which is used in Linux-oriented OS endpoints. AuditBeat is also from the Elastic family, and it also provides information from the endpoint with respect to auditing, specifically file auditing, file activity auditing, and others. Moreover, these are highly configurable, and they natively understand the log files of many different application software, which is to say that they can consume it on the endpoint, potentially transform it, and send it over directly to wherever you want them to, right? And the destination could be, but they are natively aware of many destinations which they can just send it over to, for example, to Elasticsearch, and they can push it to Kafka, etc. It's very highly configurable, all of these endpoints. All right, so this is layer one, which is collection of data through direct and indirect data sources. The direct data sources are the logs of operating system, logs of applications, and application-oriented data coming from an application API, as well as the network traffic. And the indirect sources are applications like Logbeat, FileBeat, Fluentd, etc., Zeek, Snort, other IDS, etc., right? This is the source. Now, with that, we move on to the next column, which is that of data collection or aggregation. So we have various tools which can potentially be used for the aggregation and collection of data. Logstash from the Elastic family is one of those. It's very feature rich. Moreover, the RSS log daemon from on Linux. It is also very highly configurable and can be used to, in tandem with a client and an RSS log server. There's a lot that can be accomplished to move data from here and there on Linux platforms. In addition to that, we can write custom shell scripts, which can be in turn fired through crond daemon. We can also write, custom other scripts like Python scripts, PowerShell scripts on Windows to do the same, right? So this is one layer. And moving on next, typically data buffering and queuing layers is also used to buffer against a disparity between the producers and consumers, which is a standard problem in computer science. And typically, we use queuing systems like ZeroMQ, RabbitMQ, or even Kafka queues to do the same. So as we move on to the data in motion in the next column, next is data transportation. So let's bear in mind that over here, data transportation is somewhat different in context and scope from data buffering and queuing. The main purpose over here is solely to buffer data, solely. And it happens to be that Kafka queues can also be used for the same, but this function is different from data transportation. And Kafka specifically is one of the best software agents to do the same, right? It works on a pub/sub or publication subscribe model, or also called as a register notify model, which is to say that anybody who is a generator of data, they can publish or notify the data on a topic. Kafka then acts as an exchange of sorts, and other people who are other software agents who are interested in a certain topic, they register or subscribe with Kafka for certain topics. And whenever data is published on those topics, then Kafka distributes the relevant data to whoever has subscribed or registered for it. This is very scalable, very feature rich, and probably the best tool to do this. All right, so with that, we move on to the next layer in this, transition of data in motion. So there is data processing that we can do during transportation as well, right? So if you remember when we talked about data sources or data collection, we could do some data processing even at these points. For example, we could configure when Logbeat, FileBeat, etc., or other software, application software, if they're whatever degree they are configurable to do the same. Likewise, we can configure Logstash, RSS log, our own scripts to do some degree of processing transformation that is desirable over there. Moreover, we can do the same in Kafka too. All right, but for main core data processing, whatever that might be, and that is the domain of SIEM, this is things like correlation of data, applying an ML algorithm, or other intense crunching where you really need processing, intense processing. Then typically frameworks like Apache Spark are used, where Apache Spark is one of the most used distributed data processing frameworks. And as we move on to the next layer of data in motion, the data, when processed, or when it's going through different stages of processing, or even when it's raw, it needs to be stored somewhere for different periods of time, right? So we need data storage somewhere. So things like OpenSearch, MySQL, Oracle, etc. Data stores are used for this purpose. All right. So data is read from these data stores based on the application logic, which happens in application code, which in turn could reside in Spark or elsewhere. So moving on to the next element, the next column in this data in motion, we go to the data visualization and reporting layer, the actual interface with the user, the typical interface with the user. So we could use third-party dashboards like, for example, OpenSearch dashboard, which is, or Kibana dashboard. It's pretty easy to make ad hoc dashboards, ad hoc reporting using them as in their vanilla flavor as they come out of the box. And similarly, we could use other third-party visualization and reporting tools like Tableau, for example, or there are many others as well. But to really have a controlled and highly customized graphical user interface, it is typical that we need to make a custom GUI. And that again is a custom GUI is also basically visualization and reporting and control, degree of control, right? In addition to that, the data in transition, which has been coming from all of over here, could potentially trigger an external workflow, and that external workflow could be doing whatever it needs to do based on that trigger. And this opens the door. For example, let's say if we have a third-party SOAR, SOAR, security orchestration technology, then we could trigger some workflow of its, or any other application, or that trigger could be, firing off an operating system level shell script or a Python script or whatever. So this is basically, in a sense, the architectural design choices and then architectural data flow, and typical what kinds of typical tools are used for building a SIEM. And interestingly, this is pretty much, with the exception of the sources of data, this is pretty much the same architecture, the same data flow, the same data in motion that is used for any large-scale data processing requirement. All right, thank you, bye.